Today we will discuss about our new subject. Subject name is logic circuits, switching logic and design theory. This other name is also called digital electronics. In this systems, we will discuss about the first. We will discuss our module first with the number systems. What is the number systems? We will discuss number systems code using the symbol that can refer as a number system or item. Different type of codes we can use to represent a particular number is called a number systems. Number systems are classified in different ways. First, we can represent like decimal number, which ranges from 0 to 9, and that base will be 0 to 10. This base will be 10, and number range is this number 0 to 9. We can represent 0 to 9. Next is a binary number systems. That base is 2, and we can represent 0 and 1. Then next is octal number. Its base is 8. Its base is 8, and number used for representation up to 0 to 7. Hexadecimal, its base is 16, and number can be used to represent in two ways. First, 0 to 9, it can be represented, and here, and for 10 we can use a. For 10, for representation of 10, we can use that a symbol. In representation of 11, for representation of 11 in hexadecimal we can use b. In representation of 12 we can use c. In representation of 13 we can use d. And representation of 14 we can use e. In representation of 15 we can use the representation of 15 we can use e. So this is the number system so decimal number system use only base 10s, and binary numbers uses two bases systems. Octal number that uses the 8 symbols, that have 8 symbols, and hexadecimal that can use both 16 symbols. This is the number representations. In binary, for numeric value of system that different. For examples, in place 8s, 4s, second s. Binary we can 8s yes, 4s yes also, 2s no, and 1s is no. Then we will discuss about the binary to decimal conversion. How to convert the binary to decimal, this conversion. First, in binary number. So binary number we can represent by how to convert a binary number to convert the binary to decimal number. For example, this is a number is given. For example, 1. For we want to convert this binary number 0001 to a decimal number. How I can convert? First, suppose that this is the any binary number. This is the binary 11001. This is the in form of binary number. This is the base 2. We want to convert this number into decimal number in base 10. How can I convert using this? Suppose that this 11001, this is the binary. For converting binary this number, first we should write this number into 2 to the power 0. For this number we should write 1 into 2 to the power 1, because this is the first place 2 to the power 0 into 1. For this plus For this number, we can write 0 into 2 to the power 2. For again this numbers, we can write 0 into 0 multiplied 2 to the power 3, plus for this number we can write 0 into 2 to the power 4, 2 to the power 4, 2 to the power 4 cross 1. For this numbers we can also write for this number plus 1 into 2 into 2 to the power 5, 2 into 2 to the power 5. 2 into 2 to the power 1, 2 to the power 0 equal to 1, 1 cross 1, so we can write plus 1, and yet 2 into 2 to the power 1, so 2 multiply 1, so this must be 2, plus 2 to the power 2, the 4 multiply 0, so 0, plus this again, this 2 into 2 to the power 3, so 8 multiply 0, so plus 0, plus 2 into 2 to the power 4, 16 cross 1 plus 16, plus 2 into 2 to the power 5, to 2 to the power 5 equal to 32 cross 1 multiply 1 equal to 32. So we can calculate this number 1 plus 2, 3 plus 0, 3 plus 0, 3 plus 16 is 19, 19 plus 32, 19 plus 32 equal to 51. We get 19 plus 32 equal to 19 plus 32 equal to 51 equal to 51. This is the decimal number of this numbers representations. So we can calculate using this number. This is how I have explained how the 51 will come. Next, to convert this number, to convert this number, this is your homework. How to do? Any one number I am doing. This is the one numbers. How to just we can write 2 into 2 to the power 0 plus 2 into 0 to the power, sorry, so we can write this, how we can write this numbers binary. If you want to convert this number, first we should write 1 cross 2 to the power 1 plus 0 2 to the power 0, sorry, here first digit 2 to the power 0 plus 0, 0 into 2 to the power 1 2 to the power 1 plus again this 0 into 2 to the power 2, 2 to the power 2 plus again this 1 1 into 2 to the power 3. So this for this for this, and this for this. In this way we can calculate. So 2, this 2 to the power 0 equal to 1, 1 multiply 1 plus 0 plus 0 plus 2 to the power 3, 8 equal to 9. So in this way you can write, calculate, this is your homework. So convert given number to decimal number. Next, this is the how can you write? We have written this in this examples. Next, we will discuss the decimal to binary conversion. How we can use the for conversion of decimal number to binary number. So for converting a decimal number to binary number, we need to divide it by 2 the process. How will convert? We can see this example. Suppose we want to convert the 13. This is the decimal number. This is our decimal number. This decimal number to its binary number. How can I convert? First step, b divided by 2. First b divided by 2, 13. So it's 2 divided, it goes 6 times and remainder must be 1. We have, and we should write the remainder here. Remainder is 1. Then again this will be divided by 2. 6 is divided by 2 is 3, and at that time remainder is 1. Again 3 will be divided by 2. So 1 times, it will go 1 times and remainder must be 1. Then this 1 go divided by 2. That one it will go 0 and remainder is 1. So how will write? So first we should take look first here, then this value we put here, and this value put here, and this value. This is the binary representation of any numbers. How would you convert this number into binary numbers? I will see how 11 should you can convert the 11 into, this is the 11 we want to convert. First we will do one problem and remaining we will have to do. First we can take the 11. First is 11. 11 divided by a 2. For converter, 11 divided by 11 divided by 2, it go 5 times, and its remainder is a 5 multiplied 2 tens, remainder is 1. This remainder is 1. Then this 5 will be divided by a again 2. So this 5 will be divided by a, this 5 will be divided by a again 2. So that must be, it go 2 times, 2 multiplied 2 is 4, and remainder is 1. Remainder is 1. Then this 2 again divided by this 2 again divided by 2 again divided by a 2. So again divided by, it must go 1 times and the remainder is 0. Then again this 1 is divided by 2 times by 2. So it divided 0 times and the remainder is 1. Remainder is 1. So we can write this equations. Remainder is 1, and you can write the decimal it's, this is the n, this is the n binary, this is the in a this is the n decimal that converts this to binary. So first digit we have to write this from here to be write 1, then again we should write 0, then again we should write 1, again we should write 1. So this is the how to convert this binary decimal number to binary. Divided by 2, take the remainder, and again how much time is can, and divided by take the remainder. In this way we can use the digital electronics. Next, so here we have to assign 2 numbers. Then again if we want to, again we can use the 16 In this manner, again we will do one problem more. We will convert the 17. How to convert the 17? You can see how we will convert the 17. Suppose that you have 17. Again, if you have 17, then how will you convert it? 17 divided by a 2 equal to 8. 8 and remainder is a 1. Then again 8. This 8 is divided by 2 and remainder is, it will go 4 times and its remainder will be 0. Then this 4 will be divided by a 2. This 4 will be, this 4 will be divided by 2 and a remainder is, it go 2 times, it go 2 times and remainder is again 0. Then this 2 divided by a again 2 and it one time and remainder again is 0. Again this 1 is divided by 2. 1 is divide 1 is divided by a 2. 1 is divided by 2, it goes 0 times and remainder is 1. So in this order we can write the this decimal first. Here decimal representation, this that in a decimal 10 is, and the 10 its binary equivalent is nothing but this. We should write from bottom, say 1 0 again 0, then again 0 3 0 1 2 3 and then 1. I think we should write again, but if some this from bottom 0 0 0 1. This is the binary representation. In this way we can convert. Next is your homework. We will say another like test. Next, this is the 4 is converted and the 17 is converted in this way. Right now we will convert the binary to decimal conversion, a fraction number, a point number after the decimal numbers, decimal conversion. If the decimal is suppose that this is the binary number. We want to convert this number into binary number. We want to convert this number of decimal equivalent. This is the binary number. So we should start from left side. First, this left side number multiply to 2 to the power minus, because 2 to the power minus will come because these number are coming after the point. After the point means after the decimals. So 2 to, that's why minus is come here. 2 to the power minus 1 into next number we can say 0 into 2 to the power minus 2. Next number we can see 2 into 2 to the power minus 3, and add all these numbers, then we can get its binary decimal number. So we can do one problem. Next problem, we can do one example. Sorry, suppose this is the number. This is the one problem we are discussing. Question we are suppose the discussion. Number 0.0 0.111. This is the in a binary number. This is the in binary number. Convert it to in a decimal number. How? In decimal means this is the base 10 binary number. This is the base 10. And how will you convert? First, we should write this number 0.11 for this now. First, after the decimal point, we take this number. We are talking about this number. This number take 1 multiply, because this number is coming. We should start from the left side. So 2 to the power minus 1. 2 to the power minus 1 is half. 0.5 multiply 1, so this must be 0.5. This must be this must be equal to point 0.5. This must be equal to 0.5. Then again we take second number from left. We should write this number 1 cross 2 की power minus 2 equal to 1 upon 4. We can write this number 0.25. Next we will take this number, third number, 0.2 into 2 to the power minus 3. 2 into 2 to the power minus 3 is nothing but 0.125. 125. Add these numbers. 8, 8, 0.5, 0.25, 0.1.25. If you add these number and add these number, so you can write also for adding 0 here. You can add these numbers, so this must be 0 here. So this 5 will here, 2 plus 5 plus 5, 5 plus 5 is 10 plus 2 12, carry is 1, then again 1, sorry, 5 plus 2 is this 5 will come here. Simply add these numbers. So point 2 plus 0.7, 5 plus 2 7, 3 5 plus 2 7 plus 1 8 plus 1 8. So add these number is 0.1. Add these number. So actually we are not able to write it. So add these number like this is the 8. So this we can write, this is 8, 0.8. So this is the decimal equivalent of, in this way we can calculate the decimal equivalent. So we have seen just 1 1 1 2 of this is done a binary form. Its decimal is 0.8. 8 7 5. This is on decimal. So this is the conversion of binary to decimal. Binary to of the binary, this binary number to decimal after when point is after the point, the number starting after the points. So this is a next we will discuss. So this how it is converted. We have seen one example, another examples. Next we will see the converting a decimal fraction to binary. Right now we have converted. Right now we have, if the binary number start after the fraction. Sorry, this is a fraction. After the fractions we number started. So simply we take start from the left side. After the fraction numbers is multiplied 2 to the power minus 1 and next number multiply 2 into 2 to the power minus 2 and next number multiply this first number from the left side from first number, that number into multiply 2 to the power 1, then next number from the left side. So we can start 0.22 to the power minus 2 in this week, and next we can start next number from the left hand side 2 into 2 to the power minus 2. If and another number is there, then we can also write 2 into 2 to the power minus 4. In this way we can do the binary to decimal conversion when a binary number started after the fractions. So this is the how we are calculating. Next we will calculate the decimal fraction to binary number. If a number is given to decimal, then how we can convert that number into decimal number. Simply we can see this example. If a number is given n equal to, if number is given n equal to 0.685, that number is given 0.685, that number we have to convert into binary number. This is the number started after the fractions. This is the fraction number. So how will we do? Solution, we multiply this number by 2 repeatedly and collect the integer bit. Multiply this number will be multiplied 2 and we can collect the integer bits. Suppose the number is 0. Number is first, this number is 0.685 multiplied 2. So this becomes to 1.375. Then we have got the new fraction. After the point is 0.375 and new bit we have got the 1. So we will put bit 1 here. This will our first fraction bit. That will again new fractions 0.375 will be multiplied by 2. This number will be multiplied by 2. Then we can go to 0.75 again. So again new fraction being got 0.75, but the new integer, there is no integer bits here, so we have to put in this place is 0. Again this new fraction multiplied by 2, so we got 1.5. Then new fraction we got 0.5 and new bit we got 1. This is our last fraction bit. Again we will multiply by 2. The new fractions we will get 1 when and our new fraction is 0. This process we will do continue until we will get the new fraction in 0 0, and that we put the new bit here. In this way we can calculate. and we can calculate this number 006 squared into point. So this is the first bit, our first bit, so 0.10112. In this way we can write. So one example we will do again, how we are converting this any fractional decimal number to binary number. So we will do another example. Suppose that we want to convert the problem we will see here. Suppose that we want to convert one number like 0.125. We have converted the 0.1125. This number we want to convert. This is our decimal number. This is our in form of decimal. That number we have to convert in binary. So what will we do? So first we should first we will take this number 0.125 multiply by 2, multiply by 2. So then we will get number, this multiplication we will get 0.25. This is our new fraction. It is called our new fraction. NF I have sorted right new, its name is new fraction. Then again we should write here is a any new bit in bit, because in pseudo bit is a 0.5, 0.0. Then again this new fraction will take the new fraction, we will take the new fraction 0.25 multiply by 2. This is the 2 multiply by 2. So we will get 0.5, and here again instead of after the before the fraction is 0, then new fraction is 0.5. So then again this 0.5, like 0.5 we can also write 0.5. So 0.5 multiply by 2. So we will get what? Multiply by 2. So we will get 1 0. So we can, here our new bit is 1. Our new bit is 1. And right now fraction is 0, because after the decimal point is the 0, so there no need to, because this is our first bit. This is called as our first bit, and this is our last bit. So how we can write? So 0.125 multiplier 10 equal to, in decimal, 0.001. 0.001. This is our decimal expansion. This is our binary expression of this number 0.0051. This is the how we are writing in this number. Okay. So we have process how to convert. Next, Next, we will discuss about the hexadecimal number. So hexadecimal number uses the 16 symbol and base is 16. That symbol must be 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 to 9. And again, instead of 10, we will write 1. Instead of 11, we will write V. Instead of 12, we will write C. Instead of D, we will write instead. So in this way, we can write. This is the 10, we can write A instead of 10, and we can write the B instead of 11. For 12, C. For D, we can write 13. E is a 14. F is a 15. In this way, so we will not write 10, 11, 12, or 13, 14, but we will write A, B, C, D instead of that. Up to 0 to 9, it can be read to 1, 2, 3, 4. Suppose that any number is 0 in decimal, that's binary will be 0, hexadecimal will be 0. In decimal, suppose that number is 1. So we have right now we have learned how to convert this decimal number to binary number. So then we convert this decimal number to binary, the 001. And again, in decimal number, in hexadecimal number, one will be 1. For 2 binary number, this you can convert, and hexadecimal is also 2. For 3 binary 001, and hexadecimal is 3. For 4 binary is this hexadecimal. So we can see for decimal numbers up to 9. Up to 9, decimal number can be written as a like a binary, like a decimal number. Up to 9, here you can see this is the decimal number and hexadecimal, both are same. Then the story will start from here. Then 10 in decimal number, 10 is and convert to binary, so we can write 1, 0, 1, and in hexadecimal this will be A. Similarly, 11 we can write B. Similarly, in hexadecimal, if decimal is 12, in hexadecimal is B, C. Again, decimal is 13, hexadecimal is D, and decimal is 14, hexadecimal is E, and if the decimal is 15, then hexadecimal will be F. Hexadecimal will be F. In this way, we can write the hexadecimal equations. Hexadecimal and binary fraction conversion. How to convert the hexadecimal to binary? So this is the representations we have seen. And next class we will continue. We will discuss about the how to convert a hexadecimal number to binary conversion. Suppose hexadecimal is a C. So C is nothing but 12. So in 12 binary, we can write 110. We have learned how to convert binary. In 3, we can in the binary 003 is there. So in binary to hexadecimal conversion, we can see if we want to convert any decimal number to hexadecimal number. And when we are so this is the process. What is the process? We first see the process. I think we are doing hexadecimal conversion here. I think we have opened more. So we are converting a hexadecimal decimal number to hexadecimal. How we are converting that conversion? So by dividing a 16. Suppose a number 47 is a decimal number. This is our 47 is a decimal number. Then this decimal number We want to convert into hexadecimal numbers. So how we'll do? So first this number divided by 16. 16. So the 47 will be divided by 16. So 16 multiplied 2 is 30. The 32 and the remainder is 15. Remainder is 15. We know the value of 15. Just we have discussed the value of 15 is a f. Just before we have discussed value of 15 is f. Then again this 2 will be divided by 16. So then it will go 0 time, but remainder will be 2. We know in hexadecimal 2 is like this 2. So this is the process how to write a number. Next we will do one another example. Suppose I want to convert. This is the 150. This is the decimal number 50 to hexa. How will we do? This is the 50. This is a decimal number. We want to convert this number into a hexadecimal number. This is the hexadecimal number. This is the we want to convert. How do you convert? First the 50. This 50 divided by a 16. The 50 divided by a 16. This 50 divided by a 16 equal to, it will go 3 times. 16 multiplied 3 is 48 and its remainder will be 2. Its remainder will be 2. Then again this 3 will be divided by a 16. Then it will go 0 times. And remainder will be what is a 3. So in this way we can write this number. So for hexadecimal 50 is our decimal representation. Decimal, then we can write this number. We can write 3 into, we will write 2. Okay, in this way we can write this number. So this is the process how to convert 2 into f. One example we will discuss another hexa to decimal conversion. Suppose that we want to convert a question, we want to convert 1. We want to convert 100. How to convert the 100? This is done decimal number to a hexadecimal number. How will you convert number to a hexadecimal number? This conversion is required. So what we'll do? For solution we will see 100 is divided by 16. 100 will be divided by 16. Then we said it will go 16 multiplied 6 is equal to 6 times. It will go 6 times and the remainder will be 4. Again this 6 will be divided by 16. It will go 0 time and the remainder must be what? 6. So we should write here 100 in decimal number converted into in hexadecimal. How? You should write here 6 and here is 4. So this is the 100 in decimal number that can be write 64 in hexadecimal number. So this is the how to convert a decimal number to hexadecimal. Hexadecimal number of fraction to fraction decimal number to hexadecimal. Same process. How to convert? To convert a decimal fraction into hexa multiplied by the fractions, the part of will 16 will still get a fraction part. For example, we want to this is the decimal number. We want to convert into hexadecimal. How will do? This number will be multiplied by 6. This number will be multiplied by 16. Then if this number will be multiplied by 16, so then we will get 805.5. Then again this 0.5 will be multiplied by 16, so we will get 8. So here integer part is 0, here integer part is right from top to bottom. So 0.0816. One example we will do on yourself. How will for practice? One example we can do. One example we can do like suppose that we want to convert this 0.25, this 0.25, this is the in binary. This number is this number fractional in decimal. This is the number fractional number in decimal. This point is here. Okay, is convert into 116 hexadecimal. How to convert a fraction number into hexadecimal? So first we should take this number 0.25 multiply by 16 multiply by 16. This is equal to how? This is equal to 4. This is equal to 4.0. So it integer bit, this is called integer bit is 4. This integer will be 4. This integer will be 4. Then again fraction is 0, so there is no need to multiply. If we multiply by 16, so this will come to 0. So then again it will be 0. So we can write here up to 0.25 multiplier 10 is equal to 4 in base 16. There is no need to write this number. You can write also here. Otherwise, if you want to write, then otherwise no need to write. So, is this the fractional number in decimal? That number can be converted into hexadecimal. So, Up to here we have converted how to write the hexadecimal number. So next class we will discuss about the hexadecimal systems, convert hexadecimal number to a decimal number. Next class we will discuss. Today